All right, that even sounds a whole lot better. And now I can see you guys. There we go. All right, we're on our way. So can't believe that we're kind of at the end of our sessions already. It seems like we just started our 5 sessions, but here we are. Just looking at the last couple of months, now just before you head into reporting on the learner outcomes. So we still have a little bit of time to catch the children who perhaps are not yet quite where they should be. But one of the things that I put into your folder that I'd like to just point out to you would be the trajectory that we can often look at for students. So for example, if they're not sort of moving forward in the way that you were hoping they were going to prior to about 6 weeks before we start kind of assessing them, where have they stalled? Like, what is the holdup? Is it the subitizing that they're not able to do to translate that into symbolic number form? And typically, research tells us students can subitize before they actually can write numbers or see numbers. So usually that's where they're going to stall. And that means I need opportunities for them to match, literally match. What does subitize 2 look like versus the symbolic 2? So if that's where they're held up, that's where I need to start working from. It doesn't mean that they don't know how to put things together as an addition. Doesn't mean that they don't know how to regroup and that 5 could show up in different ways, but they might be stalled at that subitizing phase. And now I need to make sure that I get them to a transitional piece where I get that symbolic going. So it's a matter of kind of finding out where are they situated and what is it that I need to do from that point forward. And that's where a trajectory can help us kind of get that sense and look for. So the same thing with addition and subtraction. I can subitize, I can group together, I could take money, I could group it together, I can count coins and put them together. Not that I need to know the value of coins, it's just the physical coin itself. I know that there's 5 of them and I can put them together, but I can't show you the number 5 because that just connection hasn't happened yet, right? So I haven't been able to get the physical symbolic piece towards that piece. So as we look at May and June, what we're really doing is finishing off just a couple of really the key pieces that go along with number. And the first one was that they acquire an understanding of quantity to 10. We've been working on that all the way through the year, starting from small, working our way up, adding on to it. And remember your bullets here, these are your understandings. So can they describe relative to each other? If they're good subitizers, you can show me dot patterns and finger patterns, and I can tell you that 5 dot patterns and holding up 2 finger patterns, that 5 is more than 2. They're able to give you that comparative language. They can talk in terms of comparison. This is more, this is less. But when they maybe cannot do the symbolic yet, if I show them the number 5, show them the number 2, that connection might not be there. So that might be the piece that we need to still work on as we move towards sliding into the assessment piece. Also, quantities can be described in relation to purpose or need. That could be really simple. That could be, I have coins in my hand. I have 3 coins in my hand. And do I need to know that it's 1 cent? No. Do I need to know that it's 10 cents? No. But I know that I have 3 coins. And maybe I've tagged things around the classroom where it says 3 of something, 2 of something, and whatever I have in my hand, do I have enough to go and buy one of those things that you've tagged in the classroom? That's a need right there. Do I have enough of those? And so that would be a translation of that. Simple. They don't need to understand that they might have 30 cents with 3 dimes. We just tagged it as 3 items. So that way we don't have to translate it into the actual meaning of the coin. It's more the understanding. Or you can say 3 bears. 3 bears in my hand as a manipulative could purchase this item, or 2 bears could purchase this item. And so I want the item that has 2, but I only have 1 bear in my hand. So then again, it's that conversation is, I don't have enough. What do I need to get more so that I can go and buy that bear, or that I can go get that bear? Then also children interpret compositions and quantities to 10. So how can I make a 10? So this goes right back to when we even brought out our Cuisenaire rods and we said, here's an orange. I didn't care that they knew that an orange was a 10. I just wanted them to have an orange. They could have maybe figured out that orange was the longest rod. But then our question was, how do you build an orange? What kinds of rods can you combine that would create an orange? That's composing. If I were to take them apart to make this, this is the decomposing side. So the same thing is true of dots, or the same thing is true of 10 in subitizing cards of just dot patterns. How can I make a 10? Well, I can have a 5 and a 5. I could have 7 and a 3. And that could come from giving me 10 bears on a plate and saying, how could you divide these up? What could you do with them? I could put some of them over here and some of them over here. Well, how many did you put on the right-hand side? You can count them. How many did you put on the left-hand side? I can count them. And together, they make 10. Now, is there another way that you can make 10? Could you have divided them up differently? That's all part of that KN2. And the other piece was patterning. Can they see the elements in a core pattern or in a pattern? Can they create that pattern for you and extend it? And then can they come up with their own pattern? And then can they extend that? So most students do fairly well with patterning. It's something that they enjoy doing. And the more different manipulatives you give them, the more opportunities they have to show you different patterns or that they understand it fully. And remember that some students may just do a simple pattern that might be red, blue, red, blue, red, blue, which is fine. But then some of them might do red, blue, but they used a little bear, a big bear, little bear, a little bear, big bear. So now I can even say, okay, so you went red, blue. Do you see another pattern? Well, I used a little bear, which was red. The big bears were all blue. So I went small, large, small, large, small, large. So again, can they see different kinds of patterns in the pattern that we've shown them? So when we talk about their quantities to 10, it's that comparative language that we want to hear from them. Do they know what's more? Do they know what's less? You and I have the same amount in our hands. I might have 3 coins. You have 3 bears, but we both have 3. So we have the same amount. I don't have enough because I can't go buy that item that you tagged for 2 because I only have 1 in my hand. So what do I need? I have not enough. What do I still need? I maybe need 1 more. Maybe I need 2 more, depending on what you're tagging. So those are the pieces that we really want to hear them start talking and saying, not just us saying it to them, but them coming back and saying it to us. And then N2 being that big one too. Can they identify quantities in different arrangements? What are different ways that you can show me 5? Show me 5 in all the different ways you can think of. Show me 6 in all the different ways. So if they've mastered 5 and you've already checked it off on their list saying, yeah, they've mastered that long time ago. Can they do 6? Can they do 7? Can they do 8? Can they do 9? Can they do 10? So we want to check for all those numbers in between all the way up to 10. And if you have some high flyers that are ready to go beyond 10, let them. Can they show you 11? Can they show you what 12 looks like? And 12 is a good number for us because if we're using a dice, then we can have 2 6s, right? So they can show us that that's one way that I can come up with 12. Yeah, Carol, go ahead.
You're just answering my question now. I was just going to ask you if that included using things like 10 frames and I see that on the next slide. So good.
Yeah, absolutely. I would definitely use whatever you can find for combinations. And it makes it even a deeper question if you give me a card that has, let's say, a rec and rec on it and fingers on it, right? Because now not only do I have to think about how did I make that 10, you're giving me a different subitizing visual that I have to actually interpret. And now I see that this is 8, and let's pick another one. Let's go 8. And do I have a small one? Yeah, 8 and a 1. Okay, so I have a dot pattern, that's a 1. So there's a way that I could make a 9. But it's fine. If I'm trying to get them to make 10, I would call out my cards to ensure that they don't end up with a 20 on there, right? So we don't want them to have really weird numbers. So take out the cards that they're not going to need if they're creating numbers to 10. And give them opportunities to see that. And that includes dominoes. Dominoes would be a great one for this, right? And we'll do that activity in just a second here. So your subitizing cards are one of the best ways for you to assess a ton of your outcomes. Can they show you, can you put the card down in front of them and they can call the number out? And they're not just seeing it in dot patterns and in 10 frames, they're seeing it in a variety of different ways. Can they combine 2 of those cards together to create 10? Or what number did they create? So they have to make sure that you're calling the numbers so that when they put them together, they're not going over a number that they can handle. If they're a child that can handle a number greater than 10, that's even better. Let's give them those opportunities. So let's have a look at a domino right now. If you had dominoes in the classroom, you could be bringing them on board. I'm going to throw this one in the chat box so that you can bring it up on your screen as well. So let me just throw that in there so that you can grab it. So the reason I'm sharing toy theater, I don't like it for everything, but it does have some really strong places that we could use it for kindergarten. One of them is a domino. So now remember that comparative language that we had. Now I could do this with dominoes in the class. I can tool it up to whatever I want. And remember that dominoes come in 3 different sizes. You can go up, buy them in 6s. And the ones that I use the most come from Dollar Tree or Dollarama because they're the cheaper ones. Dollar Tree has the multiple colors on them, so that's the one that most people like. If you want to buy a 9, you can order 9s. You can go to Walmart and get 12s as well. So now I can have 12 plus 12 is 24, which is more of a grade 1 combination. But again, if you've got some high flyers and they're ready to see something a little bit different. But on toy theater, we can go up to 9s. The way I have it set right now, I am showing 1 domino, and the maximum that I can have on each side would be 9 dots. So in this case, what could I ask students to do? I could ask them a couple of things. I could say, which side has the bigger number? And tell me what that number is. So they would quickly look at it and say 2. And then I could go to and just hit new again. If you hit the button new, I see and so in this case, I get 7. So here's what 7 looks like. Now I'm not going to use that if my children aren't ready for a larger number. I might want to just limit it down to 6. So to change what I see, all you have to do is click on the number 9 and select what's the maximum you want. So notice that you can scale it all the way down to 3. So if I have a child who can't subitize or do numbers yet all the way, then I can adjust the dominoes so that the maximum I see is a 5, for example. So when I go new, I'll never see a side larger than 5. There'll be always 5 or smaller on both sides. So in this case, I could show it and say, what's the largest number? I see a 5. Okay. What if I said, how much do I have on both sides when I put them together? So now again, remember in kindergarten, we want them anywhere from 1 to 10. They should have mastered 5, but anywhere from 1 to 10, I should say, find 5. And now can you continue counting on to tell me how much more you would have? So I should be able to count 5, 6, 7, 8. So this would take me to 8. Some students will count 5, 6, 7, 8 on here, and that's fine. But that's part of kindergarten already, is to start at a number anywhere from 1 to 10 and then keep counting from there. In this case, we're asking them to end at the size that this one is. So again, I could go new. In this case, I end up with 5 and 5. So what do 2 5s give me? Well, it depends. If I've done work with Rec and Recs, they already know there's 5 reds and 5 whites, and 1 row is 10. So that they might say that's 10. So it's not enough for me as a teacher just to hear 10. If they just call us out and say there's 10, my question should logically be behind that. How did you know that? So whether they said, well, I know that this is 5 and I know that 5 and 5 is 10, or I know that there's 5 red bees and 5 white bees on a Rec and Rec, and I know that that's 10. What is their thinking so that we understand how they got to that number? Not just give me the number. The number is right, but how did you get there? Was it just a lucky guess that you had? So the dominoes give us that. Now we could also ask them questions like, which number is larger, right? That gets into that comparative language that we just looked at. Which is greater, which is smaller? Which one has more, which one has less? The other activity that you could do at this time of the year, which would be a great telltale for you again about where they're at, is just have them take a bunch of dominoes, turn them face down. Each student gets their own piece of paper and just draw a line right down the center of the paper. And on the left-hand side could be smaller, on the right-hand side could be larger, or whatever, however you want to phrase it. And then I would turn over my domino, and let's say this was the one I turned over. If smaller was on the left, then I would flip this domino around and I would put the center of my domino goes down that center line that you created. The 2 will go on the left and the 3 will go on the right. So I can walk around and see how the kids are doing. And I can see that, do they actually have all of their smallers on the left and all the larger ones on the right? And then begs the question, what happens when I get a question that looks like this, where both numbers are the same? Then those are the ones that we turn vertically and we set them right on the line, because they're not bigger and they're not smaller. So we said they sit in the middle, they're neither nor, right? So we just set them there. Some teachers say, well, we'll just take those off and we set them to the side because neither one was larger or smaller. We usually like to leave them on there so that we can say that the middle line meant that everything was the same. There was no greater, there was no smaller. So that's another way that I can use the dominoes in the same way that I could sort of navigate the waters of a subitizing card. I could have 2 subitizing cards turned over at the same time and use that same sheet of paper with a line down the center. Which card had the bigger number, put it on the right. Which card had the smaller number, put it on the left. So whether it was 2 fingers and dot patterns or whether it was tally marks and dot, it doesn't really matter. They turned 2 cards over at the same time, and now they're going to place them side by side, but which one is less, which one is greater, and put them on the right side of the line based on how you labeled it at the top. So the dice or dominoes give us just as much of an advantage as the subitizing cards do. The only disadvantage is that they only ever see dot patterns. And if we've only got children that can only deal with dot patterns, then this is where you want to stay. Then you don't have to call out anything out of your pile. You just use dominoes because they give you that advantage, right? And there are some students that will only be able to subitize with dot patterns. Just again, the research tells us that students subitize before they actually learn numbers. So at age 3, students can subitize before they actually know what the number 3 even looks like or means. So it's a natural progression. Kids see quantities before they understand what quantity is. If you show a pile of things to a child, even a toddler, who isn't really even walking yet, they're sitting on their blanket, and you put toys in a pile and put a single toy on the other side, they will reach for the pile, the more, right? They go for more. They understand that understanding of more is already there. How much more is definitely beyond them. Okay, let's go back. I'm going to draw another one. I'll put this one into your chat box as well, because dice offer me the same opportunities that a domino or a subitizing card does. And this particular site gives us a couple of extra little bonuses, I think. So I'll let you bring that one up. So again, if I'm really, really wanting students just to tell me which number is larger, which number is smaller, which is greater, which is less, however the term you're going to use, and I want to make sure that they know the symbolic 1, 2, 3, 4, right? That they can actually write it out. Then I might want to use the dice and not use one that has dot patterns on it. So in this case, the one here tells me how many dice I want to roll. And when you go to this triangle one, you see all the ones that are available. So for kindergarten, I wouldn't use the bottom one and I wouldn't use the top one. Both of those are quite confusing for them, and they can't really easily differentiate what the number is. And this one is way beyond what they need to go anyway. But anything in between. So let's say I pick the green one because it goes up to 12. So if I throw, they hear it, they see it, they watch it roll. What's the number that came up? This one will go up to 12 on here. So again, choose based on what your students can do. So the green can go up to 12. If I don't want them to go up to 12, then maybe I'll grab the blue ones, one of the 2 blue ones that are in the middle. And when I roll this one, I'll just stay with 1. So in this case, the dot tells me that's the bottom. So this is the number 6. That's how I read that. So this is the number 6. And this one will go up to, I believe, 9 or 8. So again, I can go back to these. I'm partial to the green one for a couple of reasons. If I change this to 2 of them being thrown at the same time, now 2 numbers can come up. I can ask them which number is larger, which number is smaller. And now I could even ask them to write the numbers down. So now we're going to practice writing our numbers, right? So put the smallest number on the left, the largest number on the right. So I'm going to write a 1 and a 12. If I throw a, this time I get 2 and 10. So again, which number pair? I have 2 and 10. Where will you write the 2? Where will you write the 10? So it's practice at writing. Also practice at telling me less than, greater than, smaller, larger, that kind of thing. Now you could change this back to 1 and you could say to them, I am able to give you a bear counter if you roll a number that is 5 or smaller. So now they have to think about 5 or smaller. What's less than 5? And so now they can roll just the one die, or you can change the die, whichever one you want. I rolled a 5. Is 5 5 or smaller? Then yes, I would get a counter. And they could do this with a partner where they roll one die, you set the rule, you pick the rule, and you could differentiate this based on wherever the students are at in each of the grades or each of the year groups, because you may have a student group that's 10 or even better than 10. So you can say 12 or smaller, right? Any number that's or whatever you decide, or 10 or larger. But if I'm only a student that can only do certain values, they will then tailor it and differentiate it according to what I'm able to handle. And then again, change the dice if I'm not able to handle these numbers. And then they can play with a partner. And if they meet the thing, then they get to pick up a counter that's sitting in a pile. And maybe after 10 rolls each, whoever has the most counters could win the game. So they're practicing all those pieces from the outcome. They're just doing it in a game format, right? So they get a sense of what that's all about. Okay, so let's keep going here. I'm just going to pull that guy down here a bit so it's not. One of the other things that I would suggest is that we also make sure that students just think that subitizing cards only look like the ones you have. They should know that they could look very different and still be subitizing cards. So here's an example where I've got points or dots put on a circle. Here's 2, here's 3. Here's one in which the dots are even different sizes. And so again, if they're not sure because they're different sizes, we can say, well, how many counters would you put on each one of these? Well, this one has 2. Because it's on a circle doesn't change it, still 2. This one is 3. This one is 3 with different sizes on it. So this piece right in here, this dot print and play, when you get the slide deck in your folder, you can just click it on. For $5, you don't have to buy the whole game. If you print it off, if you're willing to print it off on your own, for $5, when you purchase this, you will get a whole set of different looking subitizing cards. So again, it gives them another opportunity to see different numbers in different ways. And in addition to that, when you print it off, they will give you 8 or 9 different games to play with them at the same time. So that's all I did, is I just purchased the $5. I printed them off. If you haven't already got these, I mean, these are quite common in classrooms, but you get them in all these different colors, all these different values that are on there. So again, it gives students choice about what they're going to see and gives you an opportunity to let them tell you what they see, because now they have to think about why they're seeing what they are. I saw those 3 together. I saw those 3 together. I saw that one sitting out on its own. Asking them what they see and how they see it. So dominoes are a great way for me to be able to figure out less than, greater than. I can combine them to figure out what the totals are. I can even take a domino and turn it sideways, just put it horizontally and say, can you find a Cuisenaire rod that matches each of the numbers? So now I can say I have a 6 and a 3. Which one of these matches to 3? I would pick out the light green. Which one matches to the 6? It's the dark green. I could stand them up and I could show. And then I could even have a conversation. Which one's taller? Which one's shorter? Which one's longer, right? There's your comparative language for measurement coming into play right off the bat. Now I've just trained a number for a length. That's the only difference that I've done. So provocations are another way for us to think about how can we spark students' thinking. A provocation is nothing more than a question, and I might take a card like this, and I might use it as my carpet time talk, and then I have 3 different centers set up in the classroom where they're going to go out and do something similar. But we practice it and we talk about what is it they're going to do at our centers. And maybe I only send each of you to specific centers because based on the center I have set up, different numbers were going to appear there. So in this case, it's saying without counting, so we're getting at subitizing, how many are there? And kindergarten students at this time of their grade should be able to subitize 2s and 1s instantly. Like that should be no big deal. The other thing is I could take a bunch, maybe not 2, maybe I put 4 on the plate. and you have that little cloth there. The cloth is there so that what if they came, everything was already set up, and they went in partners, and the partner holds up the cloth for just a second and puts it back down again. And now somebody has to think about, what did I see? So we could practice doing that even in carpet time. I'm going to show you something on the screen, but only for a second. And then I'm going to take it away. And I want you to close your eyes and think about, what did you think you saw? How many were there? And then put it back up again. And first of all, let them see if they got it right. And secondly, if they got it right, how did you figure out what the number was there? What was your thinking? No two children, no two adults will subitize the same way. So if we did this with 6 items on a cookie plate, and I asked every adult that was on screen, how did you see that? And what did you figure out? What were you looking for to add them up? Some of you will see 2 2s and 2. Some of you will see 3s and 3. Some of you will see a 4 and a 2. It's important for kids to hear what other kids used to figure out a subitized total, because people do not think the same. And you as adults, your brain will give you an answer. If I put a whole bunch of scattered dots of 20 up there and show them to you for 3 seconds and then take them away and say, how many do you think you saw? Your brain will give you a total based on the experiences that you have seen to date. And that's been patterned on your brain. So again, even every adult will not answer the question the same. These provocation cards come from a box called My Math Path. It was written specifically for kindergarten. It's not a series for 1, 2, 3. It's just for kindergarten. And so the card shows you an idea that we can talk about with students and that you could set up in your classroom. The back of the card gives you questions to ask the students, but it also gives you sort of a yellow, green, red kind of scenario traffic light. So if you ask the question and they are totally off base, what could you follow up with? That would be the red group. So they are not with you at all. They did not even come close to what they should be doing at this point. So how do I follow up with them and get them back on track? The orange or the yellows would be the students who just, sometimes they get the 2s, but for some reason, they're not answering the 1s. So is that because they just think you know that, you already know that, or they should know that and they haven't said it? So just a bit of a deeper questioning dive that you might want to do with them. And then the greens are the kids who answered everything right off the bat. What are you going to do with them? So where do you take them for the next step? So that's kind of on the back of these provocation cards. This is a sample of how we integrated a study that we did with butterflies. So we were studying butterflies in kindergarten, and it has so many math connections that we just tied them together. So in this case, we learned that butterflies land on flowers. They drink the nectar. They're attracted to the color, blah, blah, blah. We learned that butterflies' wings look the same on both sides. So we used that thought to also work on subitizing. So we said, what does a 5 look like? And they don't have to have the typical that you see on a dice, the 4 corners and dot in the middle. What does a 5 look like when we look at dot patterns or finger patterns or whatever they decided they wanted to use? And so when they would draw their pattern on one side, we would say, but what do we know about the wings of a butterfly? So we kind of incorporated science at the same time, and they had to do the same thing on the other side. So we had read books about butterflies. We also had set up, these are very small ones, and these would be very beginner ones, but there's a 1 card. These come from those other cards. Here's a 2 card. What ones do you have? One that would be dropped into the 2s. Which one are reflected by 2s? So these 2 would go in here. What ones do I have that reflect a 1? And then it got deeper, much bigger than that for the next group. So we had pails, and we have tubs in here where there's 1s and 2s. There were 6s and 7s. It was whatever they had and whatever we were working with. It could be just little beads that we had that were butterfly beads or buttons. And we just said, put those into each of the containers. So we subitized, we counted, we regrouped, we added, we put things together. Again, you're meeting your outcomes. So you're meeting all of those different pieces as they go through. So in this case, again, students would draw their dot patterns. Some of them did lines on them, so they had to do their lines here. They could reflect whatever number they wanted. And in some cases, we said, what's the highest number you can count to? And if they could go to 10, we said, show that to us in a pattern, whether it's a dot pattern, whether it's a line pattern, a finger pattern, whatever. And then they had to come up with the same thing, draw them in. So again, with your science coming into play next year, keep that in mind. Because there are lots of places where the science and the math in the kindergarten will absolutely blend together very, very nicely. So I can do them at the same time. This is another example of where we had them find numbers. So this would be like a scavenger hunt. Your kids should be at a point now they could get a scavenger hunt where you randomly give them 2 numbers in a team and they have to go find 5 of something in the classroom of that number. That was my number. Maybe my number was also 4. So me and my partner and I have to go run around and we have to go find 4 of the same thing. So just a quick scavenger hunt. And in this case, what we gave them was, this is for Play-Doh. And we asked them to create what they knew about butterflies. But in another picture, but I didn't put it on here, these mats that we used for rolling out clay were actually bins that were filled with beads, in some cases just sand. And what we did is we hid numbers in there. So little plastic numbers were 2s, 10s, 8s, 7s, whatever. And they could dig through the sand, find the number that they would pull up. And on the back of the number was a picture of a butterfly or a flower. And then we had hidden butterflies all around the room. We had hidden flowers all around the room, wherever. And if they showed up a 4 and on the back it said butterflies, they had to go find 4 butterflies. So it was a little bit of a fun thing to go dig for the number, but now they had to show us that they knew what the quantity was. They could go find it, and then they would bring those quantities back to us and show us. So a scavenger hunt, that kind of a dig is a really appropriate thing right now for kindergarten to connect those dots together for them. We also want to make sure that they understand that conservation of number, right? So I could give them, for example, this is only 3, but there's 3 Legos there. So they could stack the Legos. You could give them 10 Legos, 8 Legos, whatever. Maybe one of them is a different color. So they stack them together and you ask them, how many do you have? So I can count them. And now maybe the one that was a different color, in this case, the green, let's say the green was on the top of my stack. And what if I grab the stack from them and I say, I'm going to take that green off. I'm going to put it on the bottom. How many do I have now? Right, there's your conservation check. Do they understand that if I took the green from the top and put it on the bottom, I haven't changed the number of Legos I have. I just changed the position of the green bar. That's all I did. So I still have 3. So the more I can do those kinds of activities with them, or they could go to a station where they string a bunch of beads. So here I put a bead on, so the students know that whatever's left on the plate, they should string it. So let's say they put a brown and I have a yellow or orange bead already on there. And I say to them, what would happen if I took the orange bead off this end and I put it at the other end to the end of the brown? How many beads do we have now? Does it change? Are they different? So what we would hope to see is that they're a different order. We'd hope to hear they're a different order, but there's still 3 beads. It didn't change. So again, it's that conservation of number that we're looking for. So here would be a picture of students that were working on just butterflies. Okay, and they were basically drawing a butterfly as a team together. And then as a class, each one of them had to fill in their number. And a lot of kids traced their hands or their fingers. And we said, remember what a butterfly is made of. The wings have the same patterns on both sides. So if I did my hand pattern over here, then I had to come over here and do the same hand pattern. So again, it's that subitizing, counting. Some students just did dots. Some students did numbers. They just went 2, 2, 2. And we said, okay, that's fine. But now I have to see that on the other side. So we have to make sure that your pattern looks the same. So it kind of combines a whole bunch of things in your outcomes all at the same time, but gets them very actively engaged in a study that's outside of just math. Another provocation card. What are different ways that I can show 5? So how many are in each group that are pictured here? And maybe you have a bunch of them set out on a table and it goes all the way up to 9. Maybe we're just getting to 10, we're just doing 9. So I've got 9 in all the different ways. You could ask them to even take a number and put the number 4 in front of these spoons and 1 in front of this spoon. And how many spoons was that then? There were 5 total. So I put a 4 card here and a 1 card here. So I see that 4 and 1 gives me 5 in total. Or here I see that I had 4 popcorn cups and 1. Or here I had 2 and 3. So again, they can walk around with these little number cards and put them down so that they can see different ways of making what. And I wouldn't tell them what the what is. I'm going to ask them, what is the same number here? What are they all the same? They're all adding up to 5. And in the end, when we deal with the outcomes, we want to make sure that they can show 10 or less in a variety of different ways. We could use those DESI tracks that we've talked about in the past, right? Where we can use our Cuisenaire rods, and I can say, show me 5. Show me all the different ways you can come up with 5. So I could put the 5 on, but now I can say, show me all the different combinations you can come up with that will give me 5. And even just flipping a color around, like green, red, red, green. In the end, it's still 5. One is 3, 2, one is 2, 3, but still 5. So it's a visual way for me to do that. Or I could do 5 singles, or I could do 2 reds, so 2, 2, and a 1. So what are all the different ways they can come up with 5? And maybe I only can do to 7 now. So how many ways can you come up with 7? What are the different pictures for 7? So again, just lining up the DESI tracks so that they can even see the numbers as they're putting them on makes it that much richer for them, because they can see how much they're adding into each of the positions when they put a rod in. This one is also in your package, in your folder. And with this one, this is a great way for them, again, to do composing. So you would call out whatever numbers you want me to work on, but let's say you only want me to work to 10. I would go and grab as many dominoes, take out anything that's going to be more than 10 when they combine them. So take out the 6, 6 and 6, 5. And then what they do, they can each have their own, or they can play as a partner, but they pile up their dominoes right on top of this domino here, face down. And they turn over a domino, and then they have to look at both sides. So in this case, I have 3 and 5. So composing those together, that gives me 8. And then I kind of drive my domino over and park it in the 8 stall. And the idea is that they need to fill up their sheet if they're doing their own before their partner does, or they just play with a partner, and whoever is the last one to fill the stalls, the last stall that needs to be filled is the winner of the game. Or you don't even have to have winners. Now you can change this, right? We just recently did a study with 2 to 5. I work with a group that is 2 to 5-year-olds. And so they were studying whatever the children found interesting. And so there was a huge group of students where this school is. They've got squirrels all over the place. So all the kids wanted to study squirrels. So all we did here is we gave them the same thing. I didn't call it car park because you can just wipe that out and change it. I called it Saving My Supper. And so we put a stuffed squirrel in here, and we just gave them a bowl of a whole bunch of beads, and we called them the nuts that the squirrel was collecting. And so they turn over it. So they had 8. So they had to find 8 nuts out of here and drop 8 nuts into here, so that when it got cold, that squirrel had some place to go. It could be if they like dinosaurs, pretend that whatever you put in the thing, get something that's green colored and call it leaves, and say you have a herbivore. Your dinosaur is a herbivore. So he needs to find lots of leaves that he can store and go and eat later, right? So whatever they're interested in, you can tool this up any way you want. You can do them sequentially in your folder. You have them in order, like 1, 2, 3, 4, 5, 6, and it goes all the way up to 12. If you don't want that, you can change it. I just created new numbers and put them on myself to go to 10. But again, if you've got some high flyers that can do some bigger numbers, let them go with that. And just make it whatever they're interested in. Just story that you just read even. That could be just something else that they could do. So the N2, remember, is that composing and decomposing. So that's where those dominoes, adding them together, that's a way to compose to get to a number. That's a great way for me to do that. Now, there's a couple of sites here that I just want to show you. The Money app we've already done. Braining Camp, some of you may already have done this, gone to this site. If you haven't, I'm going to put it into the chat box here. Now, this one does have, there's a subscription to it, but I'm going to go back to my slide deck just for a second. You see this yellow Teacher 23, all capital letters, 23, no space. If you've never been to Braining Camp before, go ahead and log in, set yourself up a login. And then at the very end, when you've got your login and it gives you your code to enter, your passcode, it'll generate one for you. Then if you go up to the taskbar at the top, it'll say redeem. And if you press the redeem word and put in Teacher 23, you will get 3 months of this for free, which takes you into summer holidays, which is plenty of time. You can push this out to students if you had been using any kind of device where they're all getting the same things, but in any case, it has some perks to it that we want to look at. So again, this link will be found on your slide deck. It's in your folder. So Braining Camp. So you're going to go in, you're going to set yourself up if you haven't already done so. And then here's the redeem button right here. So once you get your code from them, then click on redeem and put in teacher 23. So I'll just give you a minute to set that up. I'm already signed in, so I won't do anything. And the two sites that we really want to spend time on here, or that would be advantageous for kindergarten, because not everything here would be kindergarten. Well, there's a couple, I guess. Cuisenaire rods would be one. And for a different reason.
I can't.
You automatically get 1 month free anyway as soon as you sign up, but we want to get 3 months. Okay, that's okay. So I'll tell you what to do, and then once we're off, then it'll be easier for you to get in. So in the Cuisenaire rods, the reason I want to show you this one, it still gives us the same things that we had when we did the New Zealand one. They're not numbered, and that's a good thing because we don't necessarily need the kids to know what the values are. But what this particular site offers that the other ones don't, notice that below the orange is another one, a new color. And the advantage of this one is when I click it on, this is a bar, I can make it any size I want. So I'm not stuck to just the orange bar, which was 10. So this is my length of 10. But what if I wanted a 12? Like what if I had a student who's ready to go on to 12? Well, I could grab a red one, put it there just to see how long it needs to be. And now I have my new bar. And I just have one bar. So I could say to students, how many ways can you make a 12? And if I'm not sure I'm going to remember, I can take my pen and I can even write, as weird as it looks, that this is 12 long. So now they can go in, they can grab the different rods and they can see that 6 and 6 makes 12. They can see that 7 and 5 makes 12, right? So I can compose it just like I did for the orange. But this is the only site that I've found so far that gives me the advantage of being able to create my own starting rod of whatever size I want students. So it lets me differentiate quickly too. For a student who is able to do more than 10, now I can create that bar for them and let them work with it. Now to go back to the main page, just go up in the top left-hand corner and hit the back arrow. The other one would be the Rec and Recs, and they're not earth-shattering, but they do offer us a couple of things. And one of them is, if I just start with the simple bar, so here's where I can confirm 5 and 5 is 10. I can subitize quickly 5, and if I say push 6, well, I should know that 5 plus 1 is going to give me 6. But I can also underneath do the same thing and say, can you push 5? So push 5. And on the next row, can you push 3? So I'm not looking to see 1, 2, 3. I'm looking for them to grab it and push it. And then how many do I have in total? So again, I can just do the composition right here. And can they see that? So it's a version of a domino, only it's done on a Rec and Rec. So again, the most you'll ever use in kindergarten would be those two. You're not going to be using this one right now. But again, you have the advantage of being able to access both of them at the same time. The other one would be the different pattern block sizes that you have, but this is not necessarily the best place for them. So again, I could use these for patterning if that's what I want, but I'm going to prefer to go to Mathagon, which I'm going to show you right away as well. And the other one would be if you need counters. So if you were doing a 10 frame and you wanted to do counters, then you could use the different colored counters, bring out a 10 frame and go from there. So you have some advantages, but the one that I really like on here was that Cuisenaire rod to create your own rod. Okay, let's go back. And we're going to grab Mathagon right off the bat too. So I'll put that one in the chat box. Mathagon, there is no sign up required because everything is free. So when you bring Mathagon up, there's a whole bunch of things that you can do at the top. They have tons of lessons done for teachers, tons of activities. I want to go to Polypad. So we click on Polypad and you'll see this whole list of menus that come up on the left-hand side. And so when I go through this list of menus, again, not everything is going to work perfectly for kindergarten, but I do like the polygons and the shapes in particular because they give me a large variety. And now I can really say, let's build a pattern that's not just based on shape, but each of them has a unique size. So now I can go small, medium, large, but here's a pattern, triangle, square, in this case, an octagon, right? 1, 2, 3. Yep. So when I go through it, so then I can go through, I could even drag another one out, but they only have to do up to 3. They don't have to do 4 in their core. So now we can say, can you come up with another one? And then what is your pattern? So the pattern could be that they say the shapes, the names of the shapes, and they have to be able to do triangles and squares and rectangles and circles. Your choice, whether you introduced octagons and hexagons, that's up to you because it was a such as example in your curriculum document. But I could also say, what else do I see for a pattern here? I see a small, I see a medium, and I see a large, right? So now I have not just color pattern, but I see a size pattern. So if they can create something that's a multiple different kind of core, that just points out to them that it doesn't always have to be just colors and alternating of the same size. And those are very similar. They're very simple ones that they can do, but absolutely this could be something we can use. Mathagon offers us way more shapes that we can do. And that's not important for them to know regular and irregular. All they need to know is that they've got all these different shapes that they could drag out and create a pattern for you to show you what you have. If I go back into, I'll go back into geometry again. If I go into Polyminos, what that is really just a pattern where we ask students to put pieces together. And they don't have to go necessarily the way you see here, but sometimes you maybe want them to follow a pattern. So can they build what they saw here? So again, it's an opportunity for them to do digitally. We have more shapes here than we can get in a classroom setting with just the blocks. So this gives me lots of different opportunities when I start putting things in and putting them together. Tangrams, we can do that. The 3D solids is another one that we would like students to be able to at least know the cube. And they should know a cylinder, which I don't see on here for whatever reason. I don't understand that one, but they have a prism. So we want them to be able to know a cube and a cylinder. Those would be very common 3Ds that we'd expect a kindergarten to know. If I look at numbers, I have number tiles. The way to get rid of stuff in Mathagon is just highlight it. And then when the garbage can comes up, get rid of it. So number tiles and cubes, that's really your base 10 blocks. That's really what this is. So if you wanted to use them as counters, great. If not, stay away from them. Here are your Cuisenaire rods. What I don't like about these is that they have the number on them. And if it's at the end of the year where we've done all this work with no numbered Cuisenaire rods, then bringing out a number is fine because we're already familiar with them. We know what's happening. Notice these are not the standard colors. This is a new color combination. So it would be very different for students to see the 10 being sort of a greenish color as opposed to the orange. When you come down to, there's a whole bunch of things and you go through these, but not all of them would be ones that you would necessarily use. When you come down to games and applications, there's a couple of things I just want to point out there as well. First of all, you have dominoes again, so you could drag them out of here if that's what you want to do. But the one that I want to look at is the one at the top about music. When I drag out the piano that's in here, this is another opportunity for me to link number counting values to a real world scenario, such as music. Music is mathematical. It's all mathematical. And so for them to even see that the keys are numbered and then they can hear them. Now, I'm pretty sure you don't want 25 of those all going at the same time, but it does give them an opportunity to hear that. And we can say, what sound does the number 3 key make? What sound does the number 6 key make? And if they know the names of music, or you're a musical person, we can even teach them the name that number 3 is, number 6 is, number 7 is. Like, what is the name of the key? What is the name of the sound? Like, is an A, a B, a C, whatever, right? So we can go from there to just giving them some connections to the real world. So it's not just about counting bears and squares and cubes and stuff that we have in the classroom, that we actually can link it to even something that's real for them. So again, it's just another neat place. And this is the only place that we have found something like this embedded in a virtual manipulative. It's free. So I mean, why not? Why wouldn't we use it? The other one that I just want to remind you of would be that floral game. And we brought this up in session 1. This is the first time that we saw it. But now's the time where they should ace it, because now I should be able to subitize my numbers. I should be able to group them. And again, you could cull them. If they're not ready to do a 6 and a 5, then that wouldn't be an option in their pile to choose from when they're going through. But what they do is they put a domino at random. You just put a whole bunch of them on the floor and they just go grab 5 dominoes, put them face up. We give them a dice, actually 2 dice, and they roll the 2 dice and they add those faces together. And if, let's say I rolled a 7, do any of my faces that I see here add up to 7? Yes, I have a 6 and a 1. I might not have rolled a 6 and a 1. Maybe I rolled a 4 and a 3. But they also learned that 7 can be shown different ways. Well, that's part of that outcome that we have. So if I rolled a 7, I have a 6 and a 1. That means that when I add them together, I get 7. I get to take that domino off my pedal. And my goal is to have my own card. Each one of you has your own card. And we keep going around the table. We keep rolling. Everybody gets a turn. And whoever clears off their pedals first wins the game. And if I roll, and usually it's when you get down to 1, you're waiting for one number, right? When you get down to the 1, if you roll and you can't move, then it goes to the next person. And then it goes to the next person. And you keep going until eventually you get them all off. Sometimes it goes really quick and sometimes it takes a while to go. This is easy. I put the template for the flowers into the folder for you. But I will say to you that if you want to Google flower petals, images of flower petals, this is where I got it from. And you can get 6s, you can get 8s, you can get 12, you can get as big as you want. So as many as you want them to play on a sheet, you can add more than just the 5. If you're going to play them as teams, then I would get a 12, something like that, because then they can stay at it and you can put 3 kids at a game and whoever pulls the last one off is the winner. That's how you would do it if they're playing on the same card. If they get their own card, I think 5 at kindergarten is lots. Let them go out for a scavenger hunt and find numbers. Let them go outside. Let them go in the hallways, or go outside with them and do an outside walk first and say, where do we see numbers out here? Like, what numbers could we see before we give them a scavenger hunt, so that they get an idea of, what do I look for when I'm doing a scavenger hunt? Like, what is it she wants me to do? So here I can see I have 2 red slides, right? I can point out to them, how many red slides do we have? 2. So there would be a picture of 2. How many things are there on here for me to count to climb up until I get to the platform, right? So it's just being intentional to show them, where would I find numbers when I go outside? If you have monkey bars, maybe the monkey bars have a circular shape in them. Maybe they have a square in them. Maybe they have a triangle shape in them. So again, you could send them out to look for shapes. So again, it's all part of the outcomes. And if they're consistently doing it well, you don't have to wait till June to say they've got it. You can check it off now. They've got it. They've mastered it. Good. We're good to go. So same thing with composing and decomposing that we've been talking about. How do I make a number? How do I pull it apart? I'm partial to hula hoops. I like the flexibility it gives me. So I might say this is a provocation. So maybe we use this as a model, and we might say when you go to the tables, you're going to see a hula hoop and you're going to see things in front of it. Now, I was just starting this, putting them all together and put them all into the hula hoop. How many cars would we have? So that's a good starting question. But you could also make this just a little bit more intentional. What if you put the number 6 inside the hula hoop and said, when you get to the station, some of the hula hoops will have a number in them. Can you put that many into the hula hoop? So now it's not just put them all together and count them. It's I have to be intentional about which one I'm going to grab. So again, it gets to that, can they compose that number that you've given them? Equally, can I decompose them? So in this example, we gave them Lego. And I gave them Lego of 2 different colors for a reason, so that when I say, can you make 2 groups, a good logical starting point for the first time to do this by myself, I'm probably going to grab the greens and put them on one of the circles, and I'm going to put the yellows on the other circle. So I pulled them apart. And then my question to the student would be, how do you know that you have the same amount that you started with? So they should be able to add their 2 circles together and show me that it's the same amount that they started with to begin with. And then as they get practiced at that, then whatever pile I put here, I wouldn't intentionally put 2 different colors. Now I want to see, can you take all yellows? If I put all yellows there, can you divide them up into 2 groups? You could even say 2 equal groups. So can they share them into 2 equal groups, right? There's another way. Can they compose them to 2 equal groups? So now they're going to go 1 here, 1 there, 1 here, 1 here. That's usually what you'll hear. So all the different ways that I can decompose, simple ones, but you can use whatever you have available in the classroom that would work. So Cuisenaire rods also gave us an opportunity to look at composing and decomposing. We did lots of practice of that, especially in session 3 and 4, where we took out the rods again and we said, can you make an orange? Can you make a blue? Can you make a brown? So here's an example of when we made an orange, we used a green and a pink. Can I take it apart? How can I decompose it? What are the parts that would make it? This is that subitizing example that I spoke to you about, that people see things differently. Some of you, when you look at this, that's your standard 5. But we also need students to know that 5 doesn't always look like this. 5 could look like this with a 1 stuck on the end, right? So that they don't get stuck to believe that that's the only way 5 can look. And I say that because even when I worked at Alberta Ed, one of the questions we had on a PAT exam one year was, using algebra tiles. And typically, this is typically the rule, people use dark color as positive, light color is negative. And in the legend, we always tell students, read the legend. But in the legend on the exam, it was flipped. So they said that the dark color was negative and the light color was positive. 3/4 of the province got a question wrong. And it wasn't because they didn't know how to do it. It's because they never looked at the legend. Because every time they had used that manipulative, the only thing that they had ever seen was dark is this and light is this. So they believe that to be true. I don't need you to read a legend because it's never going to change. And the answer is yes, it can. So that's why it's important for kids not to just always believe that the die is the only way they're going to see a 5. This is another way. And some students will say, well, I saw a 3 and a 1 and a 1. And some of you might have looked at this just now and said, I saw 2 and 2 on the end and a 1 in the middle. It's important for them to hear each other's thinking about what they saw and how they saw it. Same thing here. I saw 2 and 3. Some will say I saw 2, 2 and a 1. You as an adult will see different things based on what you've seen and what your brain has been accustomed to. There are new dies out as well that you can buy that have subitizing sizes on them that go all the way up to 9. So instead of just using the traditional one where we just go up to 6, I can have some that have multi-sides on them and then go up to 7, go up to 9. And then they have to use their subitizing in order to figure what the value is. So there's another way that we can do that. Oops, I'm going to go back to this one here. Some of you may be very familiar with Steve Wyborny. He is a math teacher who has graciously over the years always put every week, he gives a new set of slides or a new set of estimating or whatever. I did share some of his slides in our first session with you, but if you want to practice subitizing, here's an example. Here's 100 subitizing slides. You can download them. Everything he has is for free. And when you go in and download these, as you start working through, more and more dots show up, and they're never in a traditional pattern. And so when you put them onto the slide deck and you show them with students on whatever board you're using, Smartboard or a whiteboard, it only shows for 2 seconds and then it disappears. And so then we say to students, close your eyes. What did you see? Remember what you saw. Watch for those patterns. What did you see? And then again, asking them, put it back up again. How many got it right? How did you see it? How did you find that you got that number? So that's a really great math talk for them to have. Down the left-hand side are all the things that he does that you can access at any time. I'm going to show you the SD Mysteries. When we were COVID, I was also the principal of online at the time, and I did SD Mysteries with kindergarten students because we had math club and I was in charge of the math club. So kindergarten students met with me once a week, and I would give them a question like this. Now, there are some that are designed for kindergarten to grade 2, some for 3 to 5, and then older students. So you would pick the ones that were for kindergarten. But how they work, they're all done. You don't have to create anything. You just pick the right age group. Let's just pick one for now. So here's an example where you get a picture. And then once you make an estimate of what you think is in there, you give your best guess, even as an adult. We'll do one in a second. Then I'm going to look down and I'm going to get these clues that he gives you. And they're all hidden. You do one at a time. And as the clue comes up, you start to change your guess, because maybe what you guessed isn't actually fitting the rule that's being followed. So with kindergarten students, I would know already what the answer was. So if let's say the number was a number like 15, then I might give them the numbers up to 20. And if I know that the number, he might say in one of his clues, the number is bigger than 10. So I would say to the students, it's bigger than 10. So what do we know it's not going to be? Smaller than 10. So then they could cross out all the numbers that we know for sure it's not going to be. So let's grab one that you can do just as adults. Get rid of you. Let's go to, we'll go to this one. So when I clicked it on, you'll notice it downloads into a PowerPoint. And you can save these. You're completely welcome to save them to your computer. He doesn't have any objections to that. So this is what it looks like. I'm going to bring it into slideshow mode so that you can see it. So here's my challenge to you. Just take a quick look at what you see in the jar. Maybe get a sense of how much you think a row is and what's your best guess for how many are in this jar, and just jot it down on a piece of paper. So whatever you think, best guess. So the students will be asked, how many objects do they think are in the glass? And depending on the age group, it'll get a little bit more difficult. We're just going to grab the first one. Okay, here comes your first clue. So the answer is a number that's smaller than 50. So you're allowed to change your guess every time you get a new clue. So if that doesn't fit with what you had, then you can change your guess. Okay, clue number 2, the answer is an odd number. So it's less than 50 and it's an odd number. Okay, we're going faster than we normally would, but clue number 3, the answer is a multiple of 3. So is your number that you guessed a multiple of 3? And if not, then you want to change your guess. Less than 50, odd number, multiple of 3. Okay, the answer includes 2 different digits. So they can't be like a 22, okay, which isn't an odd number. And neither of the digits is a 2 or a 4. So if you have a 2 or a 4 in your guess, then you are incorrect. Check again. So once we've gone through all, and if they're younger children, I always give them some way that they can start eliminating numbers on a piece of paper, because eventually what happens is you usually get down to 2 or maybe 3. And then we ask them to circle what's a reasonable guess based on that. So the reveal will always come up in red, and your answer is 39 objects is what was in here. Now he's got hundreds of these because he's been doing them for years. They're great for getting kids to think mentally, but they're also great just for something different to start your morning routines off with. So again, you can go in, if you subscribe to his email, he will send them to you every Tuesday morning. He just does. I have them on my email, and he just sends me the new ones that he puts out every week. Okay, we did that one already. So again, I can look at what is larger, what is smaller. I can, however I want to compare them, I can put 2 cards together, which number is larger, which one is smaller, whatever rule you want me to do. I can use all of those just for quick call outs even, which is of the pair, which one is smaller or which one is larger. We had our game that we looked at a couple of sessions ago where we put numbers on a number line. So we said limit it to 10, but if you have some high flyers, maybe you want to go to 20, maybe you want to go to 15, depending on what their count was. So you had your cards where you just simply had to cut up a row that gave you 10 numbers. And then we could take those numbers and put them on a number line. So if I drew a 6, could I find where 6 goes onto a blank number line? And kindergarten students should see numbers on a number line. That shouldn't be foreign to them. So again, if I don't know anything yet beyond 5, then that's where I'll limit it. Maybe I can only go to 9, then limit it to 9. If I get ready to go to 10 or beyond, then limit it to 10 or beyond. And then the last piece that you have at the end is a number of different links. Some of them we've already gone to, but a couple of them I just want to show you. The NZ Math, remember that was the country that we went to for the Cuisenaire rods because they were unlabeled. But this time I'm not going to the Cuisenaire rods. I'm going to what's called teacher material. And in the teacher material below that, you will find a whole bunch of different tasks and activities. All of them can be edited. You can take bits and pieces of it, but they're great thinking ones. And they start at foundational year. Anything that's called foundational in theirs is kindergarten. And then they work their way up from there. So have a look at some of those because there are lots of great resources on there for students and for you to use. The other one is Ontario Math. I have shared this one with you before, but I just want to take you back to it. Ontario Math at the very top here, I know it's hard to see right now, but they have number, algebra, data, spatial sense, financial literacy. Now this is Canadian, so that works well for us. It starts in grade 1 to grade 8, but a number of their grade 1 outcomes are our kindergarten outcomes. So how this works is I just select which I want to work on. Let's say I want number because that's a big one. When you get into it, you just look at what you see in the table and read the descriptor. And if you see a descriptor that goes, oh, wow, that's exactly what I'm doing right now in kindergarten, just click it on. This might not be it, but just click it on. And then what happens is you get a whole bunch of either games or resources and or both that would be appropriate for what you just read the descriptor for your grade. And you have access to all of those and use them with your students or create stuff for your students, whichever you want. So it's a great tool to go back to. And the other one is LT Squared. This site is specifically for students from birth to grade 3. So it is a very progressive site as far as difficulty level. And as I start working my way through, I find things that are going to be very appropriate for kindergarten. So again, explore the games, but the resources are kind of where I would like you to spend a little bit of time. There are 2 things that you can go into. The teacher one, obviously, will give you resources, but the PD that they have posted here also unpacks a whole bunch of things for you of different topics. So if you want some quick PDs on a PLC day that you just want to do for yourself, then you can go through the list here and see what's available that you would like to have, or go into materials. If there's some section there like number cards, dot card, things like trajectories, there's another one, tangram puzzles. So this is specific for little kids. This doesn't go larger than grade 3. So this is a great site for you to spend a little bit of time exploring. And in fact, when I go back to it, I'll just mention that this is where I got those number lines for you, where we did the subitizing. They had the number, the subitizing value, all of that was on the number line. That comes directly from here. And I believe here they are right here. So the learning trajectories show you how a child progresses over the years of birth to certain ages. And that's what these trajectories will give you. So when you click on counting, for example, I get all of these different trajectories. I see I start with a chanter, then a reciter, then a corresponder, a counter. Every time I get a new level in the trajectory, if I click it on, there are sheets behind there or activities that you can do with the student. So tons and tons of stuff here for kindergarten. Very appropriate. It's kind of the one-stop shop for kindergarten that I would suggest you go to. Okay, so that pretty much, the rest of these are okay, but they're not the big ones. The LT squared is the biggest one for you. So again, you have my email. Don't ever hesitate to reach out, even though we've done our sessions. If you have anything that you need, in fall, I will put together some sessions again that will be specific for grades. Like, we're not going to unpack all of this, but we'll add on some things to it. So now that we've been through it once, you don't kind of have to learn everything from scratch again. So we'll just add a few pieces into it. So just watch for those. They won't be every 6 weeks, but they will be some there that you can have. And then you'll have additional resources that you can add to your pile that you've been kind of accumulating from here. The site that you have right now will not go down. It'll stay up. It'll still be up next year. So you can always go back to it. It's not going to disappear on you. So you'll have access to everything that's there. Are there any questions? Anything that I can help with right now before I'll just stop recording here.